Hi guys, welcome back to a brand new video. In today's episode, we're going to be working on a little project, creating a TCP server and a TCP client, get them talking to each other. We're following Beej's network programming guide, and this is actually, we've effectively covered most of the parts. So this is going to be a bit of a project video you can follow along with. But for the reference, okay, we are going to be effectively creating just the server and the client. We're going to get them talking to each other, but we're following the example given on Beej's guide. Okay, so if you see me looking down, I'm following the guide, follow along with me, program with me. Again, that's how you learn. If you want to become a programmer, you've got to program, you've got to actually build stuff. So that's what we're doing, but you don't need to reinvent the wheel. You know, it's good to just effectively do what's already been done before. You'll learn more from that, I'm sure. Okay, so I'm in an empty folder here. Okay, so you can see there's nothing in here. Just going to open NeoVim, which is going to be my text editor. You guys can use wherever you want, and we're going to create a server.c file. So without further ado, let's get started. I'm going to try and speed up where I can, and I'm also going to try and effectively cut out bits that, you know, are just me waffling. So there's going to be a lot of waffling in this, I'm sure, but I'll try and leave it as uncut as I can so you guys can follow along, even if you don't have the guide open. So first thing we're going to do then is input a bunch of header files, which is a bit of a pain really, but we're going to do that. So we're going to import the usual ones really that we expect to see. Standard library, input output library, all of these. For those of you who are new to the channel, this is Bare Metal Studio. Effectively, I'm just trying to learn C from start to finish. That was the goal. I'm very well aware that you can't learn this language from start to finish, but effectively learn as much as I can. We're about 9 months into this kind of project that I started now, this goal of learning C as, you know, in much depth as possible. And so far I've learned a lot, and, you know, we've created a bunch of different programs, worked on a bunch of different projects, most notably the Alexa project, which people seem to enjoy, so thank you if you watched that. For those of you who don't know what Alexa is, where you break down input and create your own programming language, but obviously didn't get that far with it. It's just creating Alexa. It's one of the stages in creating your own programming languages. But tokenization is used everywhere, so I'd encourage you to go watch that. It was quite fun, quite interesting. I made mistakes, I learned from it, and people in the comments, actually, again, this is what this channel was all about, creating a community. People in the comments would tell me where I went wrong. So if, you know, I do anything wrong in this video, feel free to just comment, I guess. Right, we're going to need string.h as well. I'm going to try and talk through this as much as I possibly can, but again, like I said, it's quite hard to kind of think and talk and explain things at the same time. Again, you know, some of this I'm not going to know about, but I recently watched a video by, I forget the guy's name, and I'm not being disrespectful. He's a very popular guy. He's much bigger than this channel, so, you know, the guy knows his stuff. He creates like ray tracing programs in C from scratch. It's really cool. I'll find his channel. I'll like talk about him in future videos, I'm sure. But I think his name is like Daniel Hirsch or something like that. He's a European guy, I'm pretty sure. But incredibly bright guy, and he's effectively doing Linux kernel development or driver development, creating his first driver, I think, in Linux, which pretty cool. He had no clue how to do it, and something that kind of is good for me to see making these videos actually is that you don't need to be an expert. You know, again, this is like a very unsexy video for me to make. I mean, I'm literally going to be following a guide and kind of trying to explain things the best way I can interpret them at the moment. But, you know, that's what learning is all about. You know, you're not expected to be an expert to begin with. You know, it actually takes a lot of practice, and sometimes you'll write stuff you probably won't have a clue about. Sometimes you don't need to learn or go that much into it, but sometimes you'll want to have an understand what it's doing. So again, this guide is so far, for those of you again who didn't follow me going over the network programming guide, it was actually quite cool, because the way Beej, for those of you unfamiliar, Beej is this guy, I forget his actual name, Brian something, I believe. Apologies to the guy who created the guide, but it's actually just effectively going over all the different system calls. That's what I'd done in the last episode. So, you know, I'd encourage you to watch it, because I think it's useful stuff, but I mean, you're probably going to get a taste of that in this video. But if you want more explanation, just watch that last video. I just read through the documentation effectively, which, you know, is probably boring for you to do on your own, so it might be actually helpful to go watch that. But I don't know, maybe you'll just want to kind of pick things up as you go along. Right, okay, so we're going to include the last header file then. I believe this is the last one, signal. Oh wait, I've included the same one twice. Oops. Signal.h. Right, okay, so that's that. Those are the header files we're going to be using for this stream socket server demo. Okay, the next thing we need to do then is define, and for those of you who aren't aware what header files are are effectively packages of code that are already on this machine that I'm calling on for my program. Okay, so for example, for the input output functions like, or procedures like printf, for example, I don't want to rewrite that function myself. that's already built into my machine, my Unix-based machine, so I can just call on include standard input output library, and it'll do it all for me. So I can use that printf function in my code, okay? So that's effectively what that is. We're going to create a port now that we want to connect to for our server, okay? So we're going to follow the guide and use 3490, and I'm just going to leave a comment here to say in the port users will connect to. The next thing we want to do then is define the backlog. Now the backlog, for those of you who aren't familiar, and by the way I wasn't before looking over the program before starting this video, is effectively how many pending connections we will have in our queue. So for example, we can have up to 10 connections, because we're going to set that to 10, and I didn't do that actually. So let's do that now. So 10, and we're going to say how many pending connections the queue will hold. I'm on my split keyboard, so my typing is going to be funny, and I'm going to make a bunch of mistakes, so apologies for that in advance, but hey ho, so away it goes. Right, so we're going to create a few functions here, a few helper functions. The first one is going to be sigchild_handler. I'm going to, by the way, there's going to be some stuff that I'm not going to be familiar with in here, so what I'm going to do is I'm going to pause the video, do a bit of research and explain it as best I can. I'll try and explain things as I go along. So this is effectively, so for those of you who aren't familiar, we're going to be using the fork system call. Now, I dedicated a whole video to the fork system call previously, okay? There's two important system calls that we should be aware of, fork and exec. They're commonly used, and all fork does is it creates a child process. What is a process? It's a program that is executing. So for example, when I run server.c, or the server executable that we're going to create, that is going to be a process running on my machine. That's it. It's effectively a program. So I've created the program, which is server, okay? And when I execute it, that is the process I then executing. Now, sometimes you'll run a program and you're going to do something inside that program, like a server, for example, where it's going to be, we're going to need a client that joins up. Now, it would be very inefficient if we just had the process handle the client, because that means we can only deal with one client at a time. So what you can do is fork and create a child client, and then effectively all of the child processes can be their own little client. There are more efficient ways of dealing with that as well, with threads and stuff like that, but we're not going to go into that. That's far too complex for this video, and it goes well outside the scope of this video. So what we're going to do then is, sorry, I've jumped ahead. We are going to typecast this as an S. So effectively what we're doing is this function is going to take in an integer S, which I believe is the process that we are going to call the signal on. I'm not too sure about that. That's something I'll need to check up. But we're not going to, oops, see this keyboard, it's just not great. But it's not going to be used. So this is going to be a quiet, so we're taking in S, but we're not going to do anything with it, I believe. Okay, so it's going to be a quiet, unused variable. Warning. Okay, so I'm following along with the comments. Next thing we're going to do is wait PID, which might overwrite error number. Oops. So we save and restore it. Okay, so that's what this bit's doing here. So int saved error number equals error number, and then we're going to do while wait PID. So we need to take in a, I'm going to take in -1 here. We need to take in a pointer to an integer, which we're going to set to null, not mul, null, and then wn no hang greater than 0. Okay, so this I didn't really explain what we're doing here. Now, right, again, we're going to kind of pick this apart maybe at the end of the video. But my general idea is when we create a child process, we need to effectively clear up all those child processes later on. So I believe this is just playing a role in setting up the signal. So for those of you who aren't familiar, right, there's two ways that we can check if a process is done or something's complete. Okay, we can poll, which is effectively constantly checking. It's equivalent to, like, say you got your phone by here, I got my phone. If I'm expecting a text message, okay, and I want to keep on checking if I've got that text message, one thing I could do is just constantly look at my phone all the time. All right, that's polling, okay? That's that. It's a poor analogy, but that's kind of the idea, right? We can constantly check that. Or we can set up a signal, which could be like, you know, for effectively alerting the CPU that something is done. And that is equivalent to my phone buzzing, okay? When my phone buzzes, a signal is sent off, I know to look at that. So that's the idea between signals and polling, the general idea. There's a great book, and I mentioned it, and I'm going to do another video on it shortly, I'm sure, about OSTEP, the book, okay, Operating Systems for Easy Pieces. It is by far the best book you will ever invest in as a software engineer, as someone who wants to get into low-level code, as somebody who's just interested in computers in general. You will learn far more about computers than any other book out there, I believe personally. Now, somebody might disagree with me on that. I'm sure they'll have their reasons for it, because again, it's very subjective. But I think one thing that you can't doubt is how fantastic that book is. So we're going to create another function here now, which is going to take in a socket address. By the way, I've never structured my code like this before, where you have the braces on the side. Normally I have it the old school way. Well, I don't even know if, I think this might be the old school way. But I quite like it. I think it makes things a bit more easier, and also you don't have to... it just looks nicer. I don't know. It's, again, subjective, but nonetheless, maybe I'll pick up something in my coding style from this video. Who knows? Right, okay, so we're going to get the socket address, and we're going to effectively determine whether or not it's IP version 4 or version 6. This is, another helper function, I believe, okay? So let's figure it out. Also, the reason I'm in a shirt, I had an open day today. For those of you who don't know, I'm a lecturer, I'm an academic. Effectively the whole reason I'm a lecturer actually in computing. Now, it might be surprising that I don't know a lot of this if I'm a lecturer, and I understand why people might think that, but it's not my area of expertise at all. Okay, my background is in GIS, but low-level programming is something I'm extremely fascinated in, and I want it to be a lesson that, again, there's no sexy way to learn it. It's quite literally just hands on a keyboard, practicing, learning things. And there's no such thing as being a jack of all trades, I personally think. I think that, people get interested in a thing and they delve deep into it, and I'm really interested in this, and I want to delve deep into it. And again, this YouTube channel, the whole reason I'm starting it is A, to document my learning process, but also B, to create a community of people, C programmers, to kind of encourage people to learn this. I think C is very daunting for a lot of people, because it is low level and you are close to the hardware. However, I don't think it's as scary as people think, and I think it's actually very friendly. And I also think that you can learn much more about C programming than you can if you just picked up an object-oriented language straight away and delve deep into that kind of developing CRUD applications style programming. I've learned far more from this than I have from, effectively any other sort of programming. And again, it's just fun for me. So, I guess some people might... when I first created this YouTube channel, I know that some people... Because I mentioned in a Reddit thread about the fact that I had an idea of doing it. And I think some people who were experienced C programmers were like, oh, well, you've got to be careful teaching people if you're not an expert. Because, I think the idea is that, if you don't know, you shouldn't be giving guidance or advice on things. But it's actually quite the opposite. I'm not trying to teach people anything, really. I mean, if they learn something from the videos, it's great, but it's just a documentation thing, and it's also learning together, and also showing that you can, grow. The temptation to delete some of the older videos and just kind of, talk about learning C and the things that I know now is great, and I've thought about that. But then my gut tells me that the reason why I started this video, or this channel in the first place, was actually to kind of, show that, hang on now, learning is not a straightforward thing. It does take, iteration. There's been times where I've recorded videos about linked lists and I've gone back to it, and then, I've struggled, and, because things fall at your head. And when you've got a full-time job, which, again, people don't understand that, there's developers, people who work in industry full-time, and that's fantastic, and they love their job, and I love that. And they learn on the job, whereas people who are just interested in this, they have to develop those skills in the evenings, and sometimes you don't get that free time, or sometimes, you always make time for things you care about, of course, I'm not saying that, but, I think it's important that, well, I don't know, I just think that you can't, you know, not everyone, okay, I'm just going to keep the format same because I was talking about that just now. You know, not everyone has that time, and not everyone has that luxury. I'm fortunate that I do have the luxury to learn this. It kind of ties into my job in some sense. You know, if I learn something doing this, then, you know, if somebody was to come up to me and say, hey, I don't understand what's going on low level here, then I can kind of break down that process easier, and, you know, that can kind of transpire then into your teaching. But yeah, no, you know, my point is, okay, you can learn this, you can develop the skills, and you can study and work hard and pick up all these skills if you just put in the work, I suppose. Very cheesy, I know, but it's true. Right, okay, what are we doing here then? Right, so we have to open a socket for us to communicate to the client, and we have to also create a socket for the client to communicate to us. Or actually just effectively find, I believe, find the connection. I don't know if I've explained this very well. I've just gone off on a tangent. Right, we have to effectively set up the socket for us to listen on, and we have to also set up a socket for the client. I think that's all I need to say there, really. Again, this was detailed a bit in the system calls video, which we covered last. So maybe go and watch that if it's all new to you. Effectively, the socket is the interface that allows us to communicate with somebody over the network. So we need to set up two of these. So we set up socket file descriptor, new file descriptor then for the client. We also have to set up a few structures, which we're going to use. We are setting these up using effectively what we had set up earlier with the header files. So we're calling on some of those structs that are working for us behind the scenes now. So we are going to set up hints, which is going to be effectively when we call get address info, which is not a system call, but we thought it was a system call because Beej kind of put that into his guide, but I don't think he explained it very well. That only aspect, by the way, Beej's guide is fantastic. Don't want someone jumping down my throat for that. But right, socket address storage, we need to set up as well. Again, I'm not too familiar with this yet because the guide hasn't gone into this so far, so let's carry on. So get address, socket address, storage, their address. So we're going to store their address. So this is going to be the connectors or the client address info. Okay. And then we're going to do sock length underscore t, the size of the address. So we're setting up a variable called in the address, so again in the size of that, which is going to be the socket length underscore t type, and then we're going to set up another struct called sig actions. This is going to be for our signal later on, which we'll deal with. We're also going to, again, I think this is for our signal that we're setting up, so don't worry about that if that doesn't make sense. Hopefully it'll make sense later. And then we got char s. Again, this is when we convert it from network to presentation. For those of you who don't know, effectively, that is a way in which we interpret network addresses, but there's also a way the machine interprets network addresses, so we can convert it. I think it's from network to presentation if we want to convert it from the computer's way of understanding it to our version. So that's your 192.168.0. whatever. So that's that, and we'll leave that then. So we also need int rv. And that's just going to be nothing for now. We're going to use that when we call get address info. Right, the next thing we're going to do then is call memset. So this is effectively, we're going to set up the hints struct. All of the values in there are going to be 0. Size of is just ensuring that it's clean effectively, and size of hints. So that's that. And then we're going to set up some of the parameters. So this is quite interesting. Okay, so hints.ai address. We're going to say effectively what we want our type of connection to be, I believe. Okay, so for example, AI, again, if I'm like misspeaking, please in the comments correct me. Again, I talked about my usage of AI and how it's helped me, because again, it's a technology that you can't avoid. You know, it's one of those things where, like, you want to use it, but you also don't want to use it in the wrong way, because people are over relying on it. There's some studies to show that people are just getting stupider because they're just relying on AI too much. And, you know, again, it's a big issue, especially in academia as well, because, you know, I heard there was a good podcast by Martin Kleppmann. So for those of you who don't know Martin Kleppmann, he had created the book Designing Data Intensive Applications. He's also lecturing up in Cambridge. This is a very, very bright guy. He's interesting because he's lecturing in Cambridge, but he's also a current lecturer, and he's fairly young as well. He worked on a startup that got bought up by LinkedIn, so he's got experience in Silicon Valley. He's, again, a very extremely bright guy, very talented. But what's interesting about him is that, you know, he talks about the challenges, and it's interesting that, you know, for example, the university that I work in, it's not Russell Group, and he works in, you know, Cambridge, which is, of course, one of the most prolific universities in not just in the UK but in the world as well. We've had lecturers from the university that I work in actually go up and lecture in there, especially from the computing department, more from the GIS background. And, you know, of course, the likes, I think, of Alan Turing worked there. Don't know if Stephen Hawking worked there. So, again, bright guys. But he was talking about the challenges of AI, and these students, you know, who, you know, it's difficult from an academic point of view, because how do you assess somebody's work, you know, if they, you know, you have to determine, first of all, whether AI is being used, and there are tools that do that for us, thankfully. But then you also have to, you know, encourage them to use it in a way that keeps them up to, you know, so, right, for example, I know people who work in the industry, they use AI, and they use AI well. And you don't want to discourage the use of AI, but you also don't want to get people to over-rely on AI, if that makes sense. Because, again, you know, go back to the original point where there are studies coming out that show that people are relying on it too much. I heard Rory Stewart, the politician, the rest is politics, you know, kind of talk about this a bit it wasn't the other day, it was a while ago now. But he kind of talked about how, you know, it's like saying, the equivalent to saying, oh, I can lift 1,000 pounds, but you've got a forklift doing it for you. If you can say, you know, I can program, but you're getting the AI to do it for you. Really, you're not, and you're just relying on it, of course, to do things for you. There's, of course, all the issues of AI about people kind of, like, you know, people kind of bragging the vibe coded applications, and then people are actually targeting them on Twitter and all that, and the application's not working. So there's a lot of interesting stuff out there, and you know, it's like you just to navigate there at the moment, it's like a minefield. But my philosophy, anyway, getting back to the original point, and this is something that I would encourage my students to do, is to, again, not saying that I have all the answers, I don't. There's literally, you know, I'm sure there's a great deal of research coming out in this area, but, you know, I think the best way to use it is actually to use it as a tool to support your learning, to use it to do tasks that you could do that would save you time and make you more efficient. But when it comes to actually developing a skill set, when it comes to actually, you know, I think, you know, deep down, like, for example, if I was to get ChatGPT to create this whole program for me, and I don't write it out myself, when you write it out, you're actually picking things up as you go along. Speaking of, by the way, get address info. What is it doing? It's getting the address info of this current server, I believe, for the server. It is effectively, we set the first one to null because we're not calling on something. We are setting up the port that we want to talk on. We're using hints to determine what type of connection we want. So we want IPv4. We want it to be TCP, sock stream. That's what that means. TCP is more reliable. UDP then is the datagram type, which is effectively not going to be as accurate, I believe. And then serve info is where we're storing the results then, okay? So that's when we're storing the results. So let's just finish this off then. So if we get an error, what we want to do is do fprintf, and we're going to say, we're going to print a standard error. So print out the error message, get address info, and then do that, new line, and then we want to say, we're going to effectively call this function, which will get the error information for us and print that out, and then we'll return 1 then. Okay, so that's that done. Oops. Okay, I don't know what I've done here. There we are. Right, okay. So now that that's done, the next bit that we're going to do is loop through all of the results and bind the first that we can. So we only have to do this for the server. So again, this is actually something that is only a bit of a pain for the server, so we don't have to do this. So let's write that out. So we're going to loop through all the results and bind to the first we can. Okay, so that's what we're doing. So to do this, then what we do is we do a for loop. We're saying P, which is our pointer to our results, okay, for our server. P equals serve info. We're going to say whilst P is not equal to null, we are going to do P equals P AI next. So this is effectively, again, this is a linked list. I'm fed up with doing that. I do it every single time. There we go. I don't know what I'm doing. It's this new keyboard. I go from going to a normal keyboard to a split keyboard, and I've done it again. Fantastic, right? What we're doing is we're looking at our server information, so the IP address that we want to connect to. We are saying whilst it's not equal to null, we're going to loop through and effectively find an IP address that we can bind to. So we're going to do a few checks then first, I believe. Again, what am I doing? If socket file descriptor is equal to socket, so we're going to do the socket system call now, and we're going to pass through the family, that'll do, and also we need to pass through the sock type, and we also want to pass through the protocol as well. So it's effectively saying we want it to be of type IP4, we want it to be TCP, so on. Okay, that's effectively it. We're just mapping it out. Again, you know, you can look at the man pages. I'll kind of talk about the man pages a little bit later on, I'm sure. Whilst that is equal to 1, what we want to do is, minus 1. Oops, minus 1. We are going to, oh, for Pete's sake. There we go. We're going to say P error. So if it's not equal, so if the socket call is equal to -1, then we're going to send an error message, error server socket. Continue. Because again, the first one that we call on might not be the IP address, so we're going to bind to. Okay. And then we're going to say, so that's why we're running through this loop through the results. We're going to call this function, which again is something that I'm not too familiar with, but I think it has something to do with allowing the socket to be, or the port to be used even after we've shut things down, I believe. So reuse, can you see reuse there? Reuse address, is it? Yeah. And yes, so we're using this variable from earlier. I wondered why. I thought that was going to be used for the signal, but it's not, so that's fine. Size of, and then we're going to pass through int, and then, like last time, equals to -1. Fantastic. Awesome. I keep on doing that and it's doing heading, but it's fine. Right, so once we've done that, then, okay, the last thing that we need to do is bind the socket. So let's do that now. So first of all, let's just do p error set sock opt, and then exit 1. But yeah, no, I'm interested. You know, if any of you have done socket program before, network programming before, you know, talk about it in the comments. You know, again, we're just creating a very simple program here, okay? And the plan is that one day I would like to create like a HTTP server that allows people to talk over the internet. You know, have multiple clients trying to interact with the server. That'd be really, really cool. Even maybe set it up on a Raspberry Pi or something that, you know, get my device talking to it. I don't know. Well, that's an idea. for another day. But for now, let's just get this simple program running. All right, so sock address, need address length, and that's it. Equals -1 again. Oh, for Pete's sake. And then close p error, usual stuff. Server bind. So if I'm guessing this is if we get an error for server bind. And then continue, I guess. And then break. Get out of this. Right, and then once we've set that up, then we binded that to a socket. We can actually free our address information now because it's not needed. So we're going to do that now. So let's get that done. So free. I wonder if you didn't do this, what would happen anyway? But we'll just do it for the sake. Serve info, and then all done with this struct. Awesome. Right, cool. Okay, so now we are currently in a good position. We've just got a few more things to do. So we've got to say, again, what is this doing? I'm not too sure a second, but maybe it'll come to me now. If p is equal to null, so if our pointer is equal to null, that means then we're going to say f print f. So I guess this is if we didn't connect to a server, if we weren't successful in binding. So yeah, so we'll say server failed to bind, and then new line, and that's that. Exit 1. Okay, cool. So that's done. And then if listen. So this is, a command that, again, a system call that we'd only have to run on this particular server. We don't have to, of course, the client's not going to listen. I don't think so anyway. Maybe I've got my wires crossed. I know it doesn't bind, but okay, let's see what happens. So, right, if listen, sock fd, backlog. Okay, this might be if the backlog is full, I'm guessing. So if the clients, if we got too many clients, then we're going to say p error listen. Ooh, yeah, no, that's right. Exit 1. Right, now this is where we're setting up the signal handler. So SA handler equals sigchild handler. And we're going to pass through, oh no, we're not going to pass anything through this. So this is going to reap all dead processes. Now, I got confused initially about this when I set up so when I was going to create this program, I got a bit confused purely because we have to effectively run a signal to say, right, if we have any dead processes, then reap them. So get rid of them. We don't want them. But again, I thought that the order of this mattered, so I thought you'd have to include this in the while loop. But apparently, if you set up the signal handler beforehand, of course, it'll effectively say execute this whenever a particular event happens. So it's quite handy to know. I don't know the specifics as to what we're doing here, but I know we're setting up the again, the signal handler. So let's just do that. Okay, right. And then let's go restart. If sig action sig child I don't know what my typing is. I apologize. Right, okay, so that's all done then. So if we get an error, this message will pop up. Sig action. I'd be amazed if I made any mistakes in this program. Oh, what am I doing? There we go. and then we can continue. Right, okay, so now we're on the main while loop now. Okay, so we'll get that done. But first, let's try and explain this a little bit. Okay, so this is a struct, SA. What does SA stand for? I'm not too sure. SIG action, I'm assuming. So we're saying the handler will be our function that we've created. SIG empty set. So I don't know what this is doing. I have no clue. The flags, I guess this is just additional information we can pass through is here. So we're effectively setting up the struct and we're going to pass it through SIG action. So we're going to say, we want to say upon this event, SIG child, these are our parameters and we set this file to null. We could look up that later again, but that's the general idea. Okay, we're setting up our signal. So let's just do a simple printf statement. We'll say server waiting for connections. New line. Just keep it consistent. Oops. The example. And then we're going to do our main while loop. So this is going to be an infinite loop. So for those of you who aren't familiar with an infinite loop, it just means we're not going to exit. The server is just going to be constantly running effectively. So what we want to do then is we are going to say the address size is equal to the size of their address, whatever that is. So size of their address. If you follow Beej's guide, you might not see some of the left parentheses, so maybe this will actually help you. For some reason, it doesn't show in the actual example. Except sock forward file directory, sorry, and we're going to pass through struct sock address. So we're typecasting by here. That's what we're doing. Just means ensuring that it's of the same type. Their address, and then also the size. Size, and then we're saying if new FD -1. Then we're going to do p error accept. Okay, cool. And then continue. So just same thing really, just in case we get an error pop up. And then this is what I was on about earlier. So effectively we want to convert it from network to presentation to a way that we can understand. We're going to pass through their address. That's what we want to convert. .ss underscore family. Get address in. Calling this one. Typecast struct. Sock address. Pointer. Their address. And then we're going to pass through what else? S, just S. And then what else? Size of S. So S is S, great. So for those of you who don't know, S is what we defined earlier. It's effectively the char array, which is of the size INET, AFNet 4 or 6, something like that. Where is it? Here. IATNet 6, which is going to be effectively the size of whatever address they've got. And that's that, I think, for that. But I've got an extra parenthesis here. I don't know what that is for. So if I get rid of that, well, no, I do need that actually. I just realised it's because of the way it's formatted on Beej's guide. Okay, fantastic. So that's done. And then we're going to printf if we've got a connection. Oops. And we're going to say server got connection from SN, and we're going to pass through S there. So that's it. And then we just got to create a child process then in order to print the message out to the client, just so we can actually see what we're doing. If not fork, then we're going to close sock fd. We're going to say if send new 4D Okay, so we're going to send, so we're going to say hello, I don't know, hello client, I guess. I think we've got to specify the size of, so we'll say 13, 0, and then we'll say -1 in case there's an error. Okay, we don't have to do that, so we just do this. P error send. Great. Okay. Close, and then the file descriptor we're going to pass through, and then exit 0. Okay, fantastic. So this is all done, I believe. Let's just check we haven't got any error messages. First, we just got to close again. File descriptor. Okay, and we have to say parent. So the reason why we're closing it again is because the parent doesn't need it. So the child closed it first, and then the parent can close it as well. Need this. Fantastic. And then we can return 0 when it's done then. Fantastic. So that's it. That's hopefully, again, we'll see if we've got any error messages. Okay, we've got an error message there. Continue. Right, okay. It's because we need exit instead, is it? Yeah, exit. So I've probably done that a few times, I'm guessing. Did I do that up here? Okay, just missing a semicolon there. Nothing big too far. I guess it's going to be a continue then, is it? So for sock opt. Okay, no, that should be exit. Why are we getting an issue? Are we missing a... right, okay, right, so here we're missing our... what am I doing? So that's that sorted. Why am I getting an error there? So a call to undeclared, right, well, it clearly not, because I've called it before, and it's not going to give me any errors. So why am I getting an error there? Right. I'm really not sure why I'm getting an error message there. Or there. Incompatible. That's why. It's meant to be family, not address, so. Okay. Right. No clue. Oh, right. Right. That explains it all. Right. It's weird how it didn't call it for the other error messages, exit messages. Maybe it's because that was the first one that I had encountered, so that's why. Anyway, let's just check this is working. So, in fact, we can just write that, and then what I can do is do here, cd into server. Right, okay, so we got that there, so let's compile that. It might be different. I'm on Mac, so you might not have Clang installed. You might need the GCC. Create an output file called server. And if I run this, I shouldn't get any errors. Compiled fine, fantastic. Okay, it's obviously not going to do anything yet because, well, that's the guide, the link for the guide if you want to. Why is that happening? Right, okay, there we go. Let's just clear that. Right, okay, so that's fine. That's all working great. Right, what I'm going to do now then is I'm going to quit this and I'm going to create the client file. So client.c. And hopefully we won't get any errors in this one as well. Right, so let's talk a little bit about this then. Okay, so Beej's guide, I'll just read it out to you really quickly. So it says, in fact, let's just get this on the screen just so it makes, oops. What am I doing? Right. Let's just get Beej's guide onto the screen because it'll make it a bit easier to see. So in case you're curious then, I have the code, one big main function, for I feel syntactic clarity. Feel free to split into smaller functions if it makes you feel better. Okay, so again, this is just one way of doing it. Doesn't mean it's necessarily the right way of doing it, of course. The whole SIG action thing might be new to you. That's okay. That code is there, is responsible for reaping the zombie processes. So what is a zombie process? Well, it's effectively a process that is there. It's not doing anything, but it's still there. We want to get rid of those because, again, it's just for clarity, for code cleanness. Just get rid of that. Again, the fork is the creating the child processes, and you can make a lot of zombie processes if you don't reap them. So your system administrator will feel agitated if that's the case. Okay, so that's it. And then again, it says that the client is simpler than the server, and that's fine. That's what we're going to do now. So we're going to have to include a bunch of different files again. I should just copy this really, but just to repeat it, just in case you guys are following along, gives you a chance to catch up, I suppose. So we have the same, I believe, as before, or less, just a few less actually. Oops. Include, what else we need? Uni, std. We're going to need error. We need string. By the way, if you guys enjoy these sorts of videos where we're just kind of working through projects together, just let me know, because you know, again, it's all about community. I'm trying to kind of interact with people as much as I can on this, but really it's hard to for me to gauge it. So if you've got any questions, you know, if you would prefer me to do these styles of videos more often rather than reading through stuff, that's fine. Again, you know, because the chances are, again, I'm trying to make it as entertaining as possible, but really kind of selfishly rather doing this for myself to kind of learn this sort of stuff in the first place. But, you know, I want to make it entertaining. So if you guys have got any tips, any advice, then let me know. Right, okay, I don't know what I've done here. Right, I gotta figure this out, because I'm assuming if I just do, what am I in? Right, okay, if I just do that, that should be it. Right, okay, there we are. Ah, pain, man. Right, okay. Okay, I've done it again. Right, there we go, that's better. Split keyboard is difficult to deal with. So, right, okay, we've got all of our header files there. What we're gonna do is define the port that we want to listen on. Oh, sorry, that we want the port, the client to connect on, or the client to connect to, which is going to be, of course, the one that we defined in the previous one. So it's going to be port 3490. So again, the port client will be connecting to. Next thing we want to do is define the max data size, which will be 100. So max number of bytes we can get at once. Okay, so I'd be interested to see how that would impact things if we were to create a client, you know, like a chat service online. But we'll come to that. We'll cross that bridge when we get to it. Right, so for this one then, we're actually going to pass through some arguments. So we're going to pass through, there could be a number of arguments, a number of clients, and we're going to pass through, of course, the effectively the IP address. I believe that's the plan of this. So argv, let's do that. I think that's right. That should be fine. Right, we're going to do effectively a lot of what we've done before. So I'll just do this fairly quickly if I can. So pass it through a buffer, which is going to be max data size. Right. Okay. Int return value. By the way, RV stands for return value, if you didn't know, but I'm sure you probably gathered that. I only know because I had to look that up before, so it's not that I kind of intuitively knew that. But anyway, right, so if the argc is not equal to 2, so we're only going to take in 2 values, which will be the we'll take in 2 values, so it'll be the IP address effectively that we're passing through. We're going to do fprintf, print out error message here. usage client hostname. So all we're going to pass through is the client hostname effectively. And then we will exit 1. Hopefully that'll work this time. I'm sure I included the right header file. Okay, so we're going to set up hints again. So let's do that now. Did I set up? I didn't create a variable for hints, did I? No, I didn't. Let's do that now. Right, okay. I do need to learn the neovim commands as well, but I just haven't got around to that yet. But I do like using neovim as an editor as well, because it's just nice to have things there. I don't know, it's just, you know, like it's nice working in the terminal. It's just much more efficient, I think. And then we'll set up our pointer then. Okay, we can come back down here and finish this off. So we're going to, what are we going to do? Pass through hints. I'm going to set all the values to 0, which will be the size of, nothing new here, hints. And then once we've done that, what am I doing? I'm in autopilot. And then what we're going to do then is do hints dot AI address info family. I don't know why autocorrect's not working for me, but that's fine. We'll do AF underscore specified, and we'll do hints dot AI. Why is that not coming up? Address info hints. Usually it comes up with the autocorrection, so I don't know if I've done something wrong somewhere. If I just right, okay. What have I done? Struct address info hints. Why is that wrong? Can anyone see what I've done wrong? So, have I missed out the header file? I should have 1, 2, 3, 4, 5, 6. Should have 9 altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I got them all. Okay, why have I got an error there? I haven't misspelt anything, have I? Struct address info. So I've got stdio, I've got a standard library, I've got uni_std, I've got error number, string, types, netdb. Right, okay. What am I doing? Right. netdb.h. Right, okay. Whew. Right, that was stressful. We got it working. Right, let's finish this off then. This bit here. So AI, what are we passing through next? I believe it's going to be sock type. So we're going to say stream, of course. Sock stream. Great. Okay, right, now we're going to do the same thing as we done last time. So return value equals get address info. And then we're going to pass through our argv this time, because that's what we want to connect to. We're also going to pass through the port. We also want to pass through hints. And we also want to pass through our serve info. Is that correct? Looks to me to be so far. Not equal to 0. Then what we're going to do is fprintf. New line. Pass through the return value. Right, okay. We're nearly done with this, actually. It's not much left to do, I believe. We've got to... Right, what we've got to do now is we've got to loop through all of the results and connect to the first one that we can, I believe. So this is, again, for the server. I could quite literally copy all of this code, to be honest. But again, just for... I guess demonstration's sake, we'll just go through it again. So p equals serve info. If you guys want to do that and just skip ahead, I'm sure you could. It's no problem. We're going to do p equals, oh sorry, p is not equal null. And we'll do p equals, Pete's sake. Don't know what the hell I've done here. There we go. P equals, it looked like it was recording a macro or something like, I don't know. Anyway, right, P equals what? What's P equal? AI next. Again, it's not. Right, okay, so we've got P serve info, P is not equal to null. We're going to loop through, we're going to walk through the list. I'm going to do if sock fd equals socket p AI family p sock type, oops, p protocol. Then what we're going to want to do is equals to -1. Then we'll do p. And then the next bit then. Okay, it's actually not the same. I lied. I tell a lie. So this time, what are we doing? We are doing, okay, this is interesting. inet n top p AI family. Yeah, this is different to the last time. So I think it is anyway. Address info. We did do this, but I just can't remember where. So right, so we're passing through the family. We're getting address info and getting the address. Oh, so we're getting the address. We're passing through S, size of S, and then we can do site. What are we doing? Printf. Client attempting to if the connection sorry, I've gone quiet. I literally trying to focus on what's going on myself here. Right, -1 client okay, so it's just doing some error checks here. So attempting to connect. So I believe this bit up here is getting the address information from, is it from our, right, yeah, so up here this is getting our particular, okay, I'll have to double check on what this is doing. This is getting the address info from our server. So that's which will be localhost. So of course, and we could break free from this then. So let's do that. And then if p equals null, then okay, that's going to bother me if I don't do the, oh. Right. Scroll down a bit, give us more room. So if we get an error, then what we'll do is we'll have f print was print out a standard error message, client failed to connect, turn to, that's that, inet n top, again network to presentation, p family, and then we get address info, do a typecast, struct address info, address s, oops, size of s. Okay. And then this will be our message to say client connected to, and then we can have the name of our server then. Or the name of the host name, wherever it'll be. Free address info, and then we can free this serve info. And then last bit then is just checking, I guess, if the number of bytes is equal to the ones that we're getting. Is that what we're doing? I think so. So sock fd buffer max data size -1, an array or something, I'm not sure, equals -1, and then we'll print out an error then saying receive exit 1. Oops, don't know how that happened. Oh, that's why. Right. And then we'll do buff. Why did I, again, I don't know why my near vim is being strange. It was an autocomplete, but it's fine now. Null terminator. I think I've made a mistake somewhere. See, it's just not, I don't know why it's not doing that. It's just pushing me over. So there's an error somewhere, but I'll figure it out. So code return 0. Okay, and that's it. I think that, like, we've literally just created our TCP client, and let's see if we get, yeah, okay. I knew there was something going wrong somewhere. I've done the same last time, I think. Right, I think, okay, we're going to have our error message. Too few arguments. So what have I got missing? So we got, right, we've got AI family, we've got get address info, we got P address, yeah. And we got S and size of. Should be fine. So what am I missing? Oh no, we've missed one. Sloppy programming. Right, okay. What have I missed? No, I haven't. Get it right. AI family, we got that. We've got get address info, which looks correct to me. Struct sock address, sock. I put sock info, sock address it is. Right. Is that correct? AI address. And we have S. Have I called the correct function? Yes, I have. I just can't see it. I can't see it. I don't know what I've done wrong. Too few arguments to call. Expected for have one. I don't know what to say. I passed through 4 arguments. I don't know what. What is that? What the hell? Okay, if anyone can spot this, I don't know where I've gone wrong here, so. Let's try it, right. So we've got, right, let's just see, make sure I haven't got any error messages further up. Ah, right, okay, this is an easy one to fix. Struct. Okay, that's strange. Ah, right. So that's fine. Struct address info. Okay, it's got the same issue. Okay, have I not included the right libraries? So we got stdio, stdlib, unistd, error number, string, netdb, types, netinetin, sys, socket, arp, inet. Okay, everything's fine there. For the life of me, I can't figure out what I've done wrong here. Right, so let's think about this then. So it's this bit here. Too few arguments. Right, it's gone the wrong function. It's going to get address info. It's actually get. Is it? Can't tell. Get in address. That's what I was meant to call for that one. But I'm getting an error with that. Did I miss a function? Did I not create the function? Don't think I did. Right, we missed out a helper function. That was the issue all along. Right, okay. Let's create that then, very quickly. Void, how could I miss that? I don't know. Right, void. So it's again, it's the same function that we created for that. Maybe that's why I missed it. Thinking I'd already done it. Struct sock address. Call that SA. So we're going to do if SA. Okay, this is like, yeah, I kind of breezed over this earlier, but that is like the most confusing bit of code you can write. Like you wouldn't write that just off the top of your head straight away. You'd have to really sit down and think about that if I wasn't following the guide. So if you just jumped in and skipped to this part, I don't know what the hell that was. Right, let's do this. So again, we're just typecasting here. So sock address in 6. We're saying if it's an IP version 6 and we want it to fit within this side of our struct. Believe address. Okay, great. So now if I do this, okay, what have I done wrong? It's just been a mistake. Like right, AF net 6. Otherwise we're returning struct. Ah, right. Where it's a pointer. Right, okay, so that's that. Now let's go down here and correct this. Right, okay, now we've got an error bit here now, or warning at least. So why is that warning coming up? I mean, it should run anyway, but let's just double check. So if the number of bytes equals receive sock file descriptor buffer max data size -1 0 So saying use the result of an assignment as a condition without parentheses, fixes available. Ah, right, okay. Right. So the left parentheses right there and right here. Great. Okay, right. Now, if all goes well after that messy situation there, what we should be able to do now is let's create the client.c executable. So create the output file, client. Great. Let's run the server here. And if I go here now and I run client and then let's give it localhost, should work fine. Fingers crossed. And it worked. Okay, we finally got it working. Run into a few errors there, even when you are copying out code. It just happens, unfortunately. But, you know, that's interesting, okay, for a number of reasons. But the reason why I like that, the reason why I find that cool is because that was sent over the network, okay. Granted, it's on my local machine. You might be like, big whoop, all of that for what? Okay, but you learn the fundamentals there then, okay? You learn how to, you know, effectively set up a socket, bind it to a particular port, how to convert someone's IP address and store it into a struct, and how to effectively send that or get the IP address from what the computer understands into a presentable format so we can see it on the screen. I find that quite cool. I know a lot of people wouldn't. I know a lot of people would be so impressed by that. But to do that in C, to get a low-level understanding, creating Berkeley sockets, BSD sockets from scratch, you know, we've learned about TCP handshake there a little bit, I guess, in a practical sense. The fact that, you know, we looked at the diagram in the last video, so you can look at that if you want to. Okay, so this is where theory meets application, I suppose, a little bit. Now, don't get me wrong, I don't understand everything that's going on in those programs, and it'd be a bit misleading for me to say that. But, you know, it's nonetheless, it's quite cool what's going on there, okay? So I don't know what the best protocol would be in terms of going forward, or the best way forward in terms of working on these sorts of programs. I guess the whole reason why I wanted to do this in the first place, okay, was A, just to do a bit of network programming because I've never done it before, so it just kind of add that to your resume, so to speak. But also as well to just get the low-level understanding of networks and again of coding. You're probably fed up if you watch these videos and you actually follow along with them. You're probably fed up of hearing me say that, okay, because I've said it on multiple occasions. But, you know, it is cool to see how the low-level inner workings happen. Because, you know, if you were to do this in Python, you would just pull a few hundred megabytes down from online, set up a Flask server like that, and it all just happens to work. And you don't really know what's going on. And I think, you know, again, I've become a better programmer from learning the lower-level workings of C. And I would encourage anybody who wants to get interested in program to learn the lower levels. You don't necessarily need to. I mean, you can get by just fine. If you're in an IT role, if you're in a programming role, if you're in a dev role, you don't need to. And again, I talked about it earlier in this episode, you know, I'm an academic. I never had to use C until I decided to pick it up myself. The only reason why is because it bothers me. I don't know if anyone gets that, the same feeling sometimes. I think if you're a programmer and you're like, you know, right, you know, you can do all this fancy analysis with packages like NumPy and Pandas and sklearn and things like that. You know, you can do all the fancy stuff for the statistics and so on at a high level, and that's fine. There's nothing wrong with that. And if that's what you're doing and that's what your job requires of you, that's great. That's fine. And if you don't need to know what's going on underneath, that's completely fine as well. But for me personally, I have developed a weird passion about learning what's going on underneath. So if you follow that passion, if you share the same kind of interests, then it would be quite cool, I think, to kind of delve deep into C. The goal that I have with this down the line, again, it's not something that, you know, I wanted to kind of conclude the series, so to speak, because I think that I could just, this is a rabbit hole that I could go down forever. I'm going to continue network programming in some facet, but I'm not going to follow along with Beej's guide. I'm going to try and effectively figure out what it would take to get, you know, to send data over, you know, using HTTP, get a website up and running where people can enter and send data that way through forms and such like that. And I feel like that'd be quite fun and quite cool to do. So if you're interested, follow along, like, comment, subscribe. I don't say it enough really, but if you're interested in joining this community, then please like, comment, subscribe, and hopefully you can learn with me and grow with me and also put me out in the right direction. And also I can teach you something, maybe. Who knows? Thank you for watching. Thank you for listening. I look forward to seeing you in the next episode, and I'll see you guys. Bye.